Hello friends, today we will discuss theory of unit number 4, which is moment distribution method of analysis. In this moment distribution method, there are three factors. First is carryover factor. Carryover factor is the ratio of induced moment at a joint to applied moment at the other joint. You can observe MA is a applied moment and MB is a induced or developed moment due to A. Therefore, carrier factor is MB by MA, induced moment to the applied moment. Carrier factor is always positive and it is equal to 0.5. Always carrier half the moment with the same sign if far end is fixed or continuous. Let us try to understand the types of the end or types of the support. Now if we see support A, it is at the end, which is called as simple support. B is a middle support which comes under the category of continuous support. C also middle support which comes under category of continuous support. At the end, roller support which comes under the category of simple support. Once again, A, which is denoted by fixed support. B is intermediate which comes under the category of continuous. C is also intermediate, that is continuous support, and support D is a simple support. If we see another example, A is fixed, B is continuous, and support C is simple support. No support is provided at D. Now if we see carryover, if we apply some moment at A, will it be carryover to B? Answer is yes, it will be possible because B is a continuous support. But if we apply some moment at B, which will not be carryover to A because it is simple support. Always remember carryover is possible if far end is fixed or continuous. Let us try to understand. If we apply some moment at B, will it be carry over to C? Answer is yes, will it be, because it is continuous support. If you apply some moment at C, it will carry over to B. If you apply some moment at C, will it be carry over to D? Just think, D is a simple support. Now it will not be carry over. But if you apply some moment at D, will it be carry over to C? Answer is yes, it will be carry over. So you will understand the concept of carry over. Let's take another example. Suppose some moment is applied at A. Will it be carry over to B? B is a continuous support. Yes, it is possible. If you apply some moment at B, will it be carry over to A? A is a fixed support. Possible. As per our rule, if the support is fixed or continuous, carryover is possible. If we apply some moment at B, will it be carryover to C? Answer is yes, because C support is continuous. If you apply some moment at C, it will carry over to B also. If you apply some moment at C, will it be carry over to at D? Just observe, D is a simple support and as per our rule, carryover is not possible to simple support. But if you apply some moment at D, C support is continuous, so carryover is possible. Now let's take one more example. Suppose we apply some moment at A, carryover is possible to B. If you apply some moment at B, carryover is possible to A. If you apply some moment at B, it will not carry over to C because next to C there is no support at D. That's why support C come under the category of simple support. But if you apply some moment at C, carryover is possible from C to B. C to D or D to C, there is no possibility of carryover. So you should remember this tagline, which is very important for moment distribution method. You should not forget this: carry over half the moment with the same sign if far end is fixed or continuous. I repeat once again, carry over half the moment with the same sign if the far end is fixed or continuous. Now Let us discuss about stiffness factor. There are only two possibilities of stiffness factor. One is 4 EI by L or another is 3 EI by L. You can observe here 4 EI by L when far end is fixed or continuous and 3 EI by L when far end is simple. Let's take some example and try to understand this. In this example, we will find the stiffness factor at intermediate joint only because stiffness factor is required for distribution factor. So we will calculate only for joint B and C. Now if we see the far end of B, which is A, is simple, that's why value is 3 EI by L. But if we see far end of B, which is C, it comes under the category of continuous and therefore the value is 4 EI by L. Now let's see joint C. For joint C, left far end is B, where it comes under continuous, the value is 4 EI by L. Whereas right far end is D, it comes under the category of simple and therefore value is 3 EI by L. If we see another example, here we need to calculate only for support B. For support C, it is not required, but if you want you can calculate, but practically it required to calculate only for support B. For support B, if we see left support A, which is fixed, the carryover factor is 4 EI by L. Right support comes under the category of simple, the value is 3 EI by L. Again, if we see joint B and C, left support fixed 4, right support C continuous again 4. If we see joint C, left support B continuous 4, right support D simple, the value is 3. So simply you have to remember 4 EI by L for fixed or continuous and 3 EI by L for simple. Now let's discuss about distribution factor, which is the ratio of stiffness of member to sum of stiffness of all the members meeting at the joint. You have to remember this theory is many times asked in the university exam paper. That's why you should remember all the three factors of the moment distribution. Now if we see here, there are three members: member BA, member BC and member BD. Let us assume K1 is a stiffness factor for member BA. And if we see joint B, there are three members are meeting and the stiffness of those are K1, K2, K3. Therefore, stiffness factor for member BA is K1 upon K1, K2, K3. Similarly for BC, stiffness of that member is K2, but sum of stiffness of all the members K1, K2 and K3. We should remember that the sum of distribution factor is always equal to 1, exactly 1.0, that we should remember. Now here we should also understand that for simple support moment is 0 and for intermediate or we can say continuous support we need to determine the moment. So you can observe here support A and D is a simple, moment is 0, whereas we have to calculate the moment at support B as well as support C. In this case support A is fixed where moment is not known to us, but support C is a overhang where we know the moment or it can be calculated. So that's some important points you must know. In this case, support A is a fixed support where we need to find the moment. B and C continuous support, moment is not known to us, but moment at D is known to us because support D is a simple support. So that must be known to us that support D is a simple support. Now, first of all, we need to find or we need to identify the moment, then we need to calculate free and fixed moment, then we need to prepare moment distribution table. You can see joint, member, stiffness, summation of stiffness and distribution factor, which is K upon summation of stiffness. Then we have to prepare moment distribution table. Then we are supposed to draw bending moment diagram and shear force diagrams. So now in the next uh, video we will see how to prepare moment distribution table. So we will discuss how to prepare moment distribution table. Thank you.